Now in this video, we want to talk about the derivative of a power function, right? Good. So you know what the power function looks like. If you have a function of this form, let's say x to the power 2, that is just the power function, right? It's just a single term of a polynomial function in which you just write the variable and you raise to some integral power. That is, you raise to some power and that power is just a whole number. So you call that a power function, right? For example, you can have x raised to the power 3. So that is a power function. Whatever you give to it, it just raises it to a power. Good. So if we denote the function as f of x, right? And then we say we have f of x equals something, then we can apply some differentiation on that function, and that leads us to having a power rule of differentiation. So let me just give you a little statement to get. So I have it here that suppose we have a function f, right? And if that function is called a power function, that tells us that the function written in terms of a variable x can be written as x raised to some power n. That is what it means for a function to be a power function. Right, great. Where that n is an integer, that is to say where that n is a whole number, all right? And they'll say possibly, right, good. So this z here just means a set of all whole numbers. So you can have negative whole numbers, positive whole numbers, and so on like that. But anyway, we can have cases where this n, in fact, is not just a whole number. It's just a fraction, any kind of constant, all right? So it would be better to say for this n being a whole real number system. That is R. So it consists of every possible number you can think of. Okay, great. Then the derivative of that function, the derivative with respect to the independent variable x. So you notice this, of that function, which is going to be the same thing as the derivative of this side, you know. This function is the same thing as this. So the derivative of this one, the f of x, is the same thing as the derivative of x to the power n, right? And when you have to differentiate that, what you need to do is, the result is going to be n here. So this power will come down, right? You have x to the power n, then the power will come down, and you write it as a constant multiple, and then you will subtract 1 from the power, and that is it. So when you have something raised to some power, all you need to do is to bring that thing down and then subtract 1 from the power. Maybe let me give you an example to explain what I'm saying. We have, let's say f of x is x to the power 2, right? Good. So if you want to differentiate that, maybe we call this f of x y. We say y is x squared. So you want to find the derivative of y with respect to x. That is, dy dx will now be, now you observe this is x raised to the power 2. Our rule tells us when you have something raised to some power, bring that power down as it was, write that thing, then raise it to the power minus 1. So we are going to bring the power which was 2 down here, that is just 2 here, and then we write that thing which is x, right? Good. And then we will subtract 1 from that power, that is going to be 2 minus 1, right? Good. And then all in all, we're going to enter with 2 times x raised to the power. 2 minus 1 is just 1, and that is x raised to the power of 1. But anyway, x raised to the power of 1 is the same thing as x. So maybe we can erase that 1 as a power, and this right here is the derivative of that function, f of x equals to x squared. Alright, great. Okay, let's move over to the next video and solve more examples on this. Alright, thanks for watching and please subscribe to my channel.